We're going to find some, or integrate some functions using separation of variables. Up to this point, we have only integrated really with one variable. Actually, we really were doing two variables, but when we integrated dy, we always just got y. But we only had one variable in our integrand. But notice, if we look at this first problem, dy over dx equals 2x over y. That first asks us to solve for y as a function of x. And we've never seen any like this before. So what we have to do is separate our variables, group everything that's got a y in it on one side and everything that has an x in it on the other side. Kind of like we did with implicit differentiation, except we grouped everything with dy dx on one side and everything else on the other. So on this one, it's pretty easy to separate these variables. If we multiply both sides by y and then both sides by dx, we get y dy equals 2x dx. And many times on the free response, I've seen them give a point just for separating the variables correctly. So then we're going to integrate both sides. So when I integrate y dy, before when we integrated dy, we always got y. So, but when we integrate y dy, we're going to get 1/2 y squared. I'm going to go ahead and put this, but just for this time, the plus c equals x squared plus c. But if I add c and c or subtract a constant from a constant, we still get a constant. So you really only have to put the c once. Now, I'm going to solve this for y, not y squared. So the first thing is to multiply everything by 2. But 2 times a constant is still a constant. And when we take the square root, we have to remember that there are two possibilities. So this is a general solution for that differential equation.
Couldn't you just write square root of 2x squared and then not put the square root over the c?
No, because we had to take the square root of the whole side.
Okay.
All right, questions on that? So that's just a general. The next part says, what if you were given an initial condition? And in that initial condition, y of 1 equals 3. In other words, when x is 1, y is 3. So I'm going to come back.
It says -3.
Does it? Thank you. Yeah, y'all need to watch me. I'm going to come back, and we can come back to this point since we have already got it to this far, solve for c. Now let's think about this for just a minute. If, when y is 1, we get a value of -3, that tells us something about which of these answers is correct, positive or negative. It's going to be the negative part, because you're getting a value for y that's negative. So that means that we're going to take the negative branch. So let's go ahead and fill in -3 equals the opposite of 2 plus c. We square both sides and we get 9 equals 2 plus c. So c equals 7. So our solution for this particular point is y equals a negative square root of 2x squared plus 7. One. We have our differential equation is dy over dx equals 4x squared y. And we know that when x is 1, y is 3.
4x and y squared.
Thank you.
You just plug in your calculator and wherever equals 1 and
All right.
Good job, Shane.
When we're asked to solve a differential equation, that means we want to end up with y equals something. So again, we've got to separate our variables. And I'm going to divide by y squared and multiply by dx. And then we'll integrate both sides. Now to integrate, it's obviously going to be easier if we raise this to a -2. Now remember, just simply separating your variables can get you a point on the free response.
Hey.
So when we integrate, we add 1, so we get y to the -1 over -1 plus c, but I don't have to put it there. I can just put it on the other side, equals 2x squared plus c. And I'm going to rewrite this as -1 over y equals 2x squared plus c. And at this point, we may as well go ahead and plug in our x and y value to figure out what c is. I think we had the point 1,3. So this is -1/3 equals 2 plus c. So c equals,
Isn't it 1 -3?
not on the bottom.
Oh, yeah.
-7/3.
C is -7/3. So I can come back up here, and we have -1 over y equals 2x squared minus 7/3. May as well go ahead and multiply through by the negative. Get rid of that. And I don't want 1 over y, I want y. But before I find y, I'm going to get a common denominator on the right side.
Oh. Don't look, don't look.
Don't quit.
Okay.
Good, it didn't quit recording. All right, I'm going to get a common denominator on this side. So that's going to be 3, so we're going to have a -6x squared plus 7 over 3 equals 1 over y. So how can I solve that for y? Flip it. Y equals 3 over 7 minus 6x squared. I just moved that minus 6x squared. It doesn't really matter which order we put it in. But that is we just solved that differential equation. All right, our next differential equation is dy dx equals 6x squared y. Okay, did I get that written down right?
Yes.
Again, we've got to separate our variables. Okay.
Adios.
Do you want me to mail this to you if I get it uploaded?
Yeah, actually.
Okay.
Right in there. If you're reading this, it's too late. At the end, okay? Put that real quick.
Okay.
It's okay, it's okay. Just got to put that.
They probably couldn't hear you.
Mhm.
So now we're going to take the integral of both sides. What is the integral of dy over y? What's it going to give us?
Y over -1.
Can we have y to the -1?
No.
No, we can't. Do we have a quotient there? What do we check for when we have a quotient?
It's a derivative on top.
Is it?
Yeah.
So this is going to be the
Natural
natural log
log.
of y equals,
So why can't you have 1
2x
-1?
cubed plus c.
the rule doesn't work if the exponent's a -1,
Oh, I mean, okay.
If you wanted to.
but it would be wrong.
Because you already have an x squared. So you're gonna add one, and add one bottom.
Okay, so now, I wanna figure out what C is. Just as easy to do it now as it would be to wait till we got finished, I think. So if we know that y is -5,
So C equals the natural log of -5.
and this is 0, so C does equal the natural log of the absolute value of -5, because this number cannot be negative, so that's why we have to put those absolute value bars there. And that's gonna be important in our answer in a few minutes when
Usually
we,
like that.
that's C. So let's go back and rewrite it. We're gonna have the natural log of y equals 2x cubed plus the natural log of a absolute value of a -5. I don't want the natural log of y, I want y. How do we solve this equation for y?
Raise both sides to e.
Okay, we can either exponentiate both sides or just rewrite it as an exponential equation, which becomes,
Did you divide by ln?
no, you cannot divide by the natural log. You'd have to divide by the natural log of y.
Gotcha.
Okay, so this is gonna be e to the 2x cubed plus the natural log, the absolute value of -5, equals y. And we have a property that we could rewrite that as e to the 2x times e to the natural log
2x
of -5.
Is it 2x cubed? Wait, can you really do that?
Yes, you can.
What's the answer?
Is it really a property? Why haven't I known
Yes,
about this?
there, you have always known about this. If you have e to the a times e to the b, that's equals to e to the a plus b.
Oh, I
That's
know
that property. I knew you knew that property.
Makes so much sense.
Oh my god.
All right, we also have a property. We have e raised to the natural log. What's that answer gonna be?
Absolute value.
Okay, and in this case, because when y is 0, the value's -5, this just becomes -5 e to the 2x cubed. And that is our
What
solution.
happened to the ln -5 again?
Is this?
How am I gonna separate this one?
You're gonna move 4x cubed y over to the left by minusing it, and then divide 4x
Factor it
back
out.
over.
Factor out the x cubed.
Why don't we factor out the 4x cubed first?
What if you were stuck with a problem that was like 4x squared and 4x cubed?
They wouldn't do that.
I'm not sure
Then you'd be hosed.
that, that it would be doable.
What's called, what's that light switch for? Let's see.
Miss Ferguson.
There's a class over there.
No, it's not. I didn't see the lights go off.
Is it?
It doesn't control.
No, I was watching the lights. It controls that classroom over there.
But there is a classroom next door. All right,
She wasn't lying. There's a
so
classroom.
now what?
Then you can divide y plus
And stuff.
and stuff.
And stuff.
Oh, like 4 I should say.
Okay, so here we can integrate. So what are we gonna get on the left side? Kelly? Oh.
I don't know.
What did we get the last time?
Do 1/3. We'll try 1/3.
You're gonna get the
Why?
I don't know what the next step is. Do you find the Because, antonym?
You're gonna get the natural log of y plus 3.
Why?
Because
because
the
dy
derivative
over
of y
y.
plus 3 equals 1.
Wait,
The natural log of y plus 3
Say that again.
equals x to the 4th plus c.
Plus C, always forget this.
Don't forget your plus c.
Don't forget it.
Because now we got to figure out what c
11
is.
points Last or 2 tests ago.
Wait, what?
That knocked me 11 points.
All right. If y is 5, we're going to get the natural log of,
8.
it's a -5 actually.
Wait, how'd you get The ln y plus 3.
Oh, that's a negative 5?
Yeah.
Yeah,
That's
you're
2.
welcome.
How did I get what?
The ln, or the natural log of y plus 3.
The derivative of the denominator's in the numerator.
Gotcha.
All right, so C equals
Natural log of
natural log of the absolute value of -2 minus 1. So, let me just keep moving it up. Now we plug it back in. Natural log of y plus 3 equals x to the 4th plus the natural log of -2 minus 1.
Whoa.
Now we want to solve for y, so I've got to rewrite it as an exponential function, e to the 4th, x to the 4th.
That's like an
I got
exponent
you.
within an exponent.
I'm going to go ahead and move this -1 here. I'm just changing places. I can do the commutative property.
I don't think that's legal.
I think it is.
I think not. Wait, Daniel, let me show you something. See this?
All right, I can rewrite this.
Wait, what about the
It
negative
is
1?
fine.
I mean, minus 1 at the end.
I moved it right here.
Oh.
Take a staircase.
So this is the same as e to the x to the 4th minus 1 times e to the natural log of -2
Which
That's what I-
is -2.
minus 3 equals y. So this becomes -2 e raised to the x to the 4th minus 1 minus 3 equals y.
Oh, minus.
Example 6 says, the rate at which a puppy gains weight is proportional to the difference between its adult weight and its current weight. Do not freak out. You don't have to come up with the equation this time.
This time.
At time equals z, it'll be easier if you have to come up with a rate. It would be an easier one to come up with. At time equals 0, when the puppy's first weighed, its weight is 3 pounds. So the weight at 0 is 3. If the weight of the puppy, t days after it's first weighed, the rate is dp, the rate that the weight is changing is 1/5 of 75 minus p. This is the rate at which its weight is changing over time. You don't have to find that. They gave you that. So just because a problem starts out looking like, I don't know how to do this, continue to read. It may give you exactly what you need. Y equals P of t is the solution to the differential equation. Use separation of variables to find the function, the particular solution when the initial condition is given. And the initial condition, they said P, so let me change this to P. All right, so what we need to do is integrate.
You gotta keep changing.
Well, I guess I'll erase those. I need to separate it before I integrate.
Oh.
Are you?
Already
I'm just gonna scratch it out.
All right, so we're going to have dp over 75 minus p equals 1/5 dt. Now we can integrate both sides.
I know this sounds
Do
See eraser.
Attention.
I have the derivative of the denominator and the
You
numerator?
do not, you almost do.
Almost. What's missing?
Negative.
I
Negative.
need that pencil back there. Now take your time.
All right, so that's the left side. What is the right side equal to?
1/5 P or
1/5 t plus c. Okay, at time equals 0, p is 3. So if we solve for c, we get the negative natural log of 72. equals C. So we have, I'm gonna go ahead and multiply through by a negative, and we'll get the natural log of 75 minus P equals negative 1/5 T plus the natural log of 72.
Wait, what is?
Wait.
Negative natural
Oh, you
log of
multiplied.
72 equals just E.
C,
Oh. Is this? Yeah.
it's supposed to be,
Oh. Sorry.
I put E2, so it's for the link, I should say.
all right,
Why is it plus?
because I multiplied through by that negative.
Oh, gotcha.
So if we solve for P, we're going to have e to the negative 1/5 T plus a natural log of 72 equals 75 minus P. What happens on the left side? What does this statement become?
Something in
That-
here.
72 e to the negative 1/52.
Minus 75.
It's coming for you, Chloe.
Equals P, but equals negative P, but we need to change that. So, negative 72 e to the negative 1/5 T plus 75 equals P.
That's enough for
Way
today.
cheese.
Yeah, I don't see how math can be applicable to real life until you get to calculus. Now I can see
You
like
really see a lot of application
Yeah, I
in
use this a lot,
calculus,
actually.
but you can't
No,
do
I like
this unless you have all of the previous knowledge.
Oh,
All right,
exactly.
the worksheet's on the back. Omit number 14.
So only do 14?
Omit 14, do all the others.
But
Water